Hello and welcome to the fifth lecture of Naughty Mojo Jojo lectures. In this lecture I'll be simply saying the Archimedes principle and explaining what it is. No mathematical derivations, and I'll be doing a problem. I will derive an equation for force. I meant no derivation for the Archimedes principle. Okay, first of all, I'll copy paste the Archimedes principle from Wikipedia. Already copied it. Yes, that is the Archimedes principle. The upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces. Now, what did Archimedes mean from this? Okay, I need another copy of this figure, so let me copy it. Yes. Okay, place it here. So what Archimedes meant. Now consider that when I immerse this wooden block over here into this water, it displaced this much water from there. Displaced this much water from there. Okay. Now assume that when we calculate the force of this water, that is mass into gravitational constant, comes as 30 Newton. Now just assume that it comes as 30 Newton. So what happens is that when we calculate the force or the upward buoyant force experienced by this this wooden piece, it will be equal to this 30 Newton. That is what Archimedes meant. He didn't mean that the volume is equal. No, sorry, the force of this liquid, or the weight of this liquid is not. He didn't mean that it is equal to the force or the weight of this wooden block. He said that the buoyant force is equal to the weight of this. Okay. Now I'm gonna move on to the mathematical derivation. So leave Archimedes alone. Leave this principle alone. I'm rubbing this off. Yes. Now this is the figure I need for the derivation. Okay, first we need to consider some things. Consider that this is actually a cube, not a cuboid. So all sides are equal. So let one side be d. So this will be d also. Okay. Okay. Now also consider that we have a pressure over this block, right? We always have pressure. The pressure of the weight of this liquid and the pressure of atmosphere. No, neglect the pressure of atmosphere. We'll consider it in a vacuum medium. Okay, we'll write this pressure as PT, pressure top, and the wooden block will also experience a pressure on its bottom. See, pressure is a scalar, so it has no direction. We'll have a pressure over here also, so that will be PB, pressure bottom. That's pressure bottom. Now it has pressure over on these sides too, over here too. So what is the difference between the pressure experienced by the top and the bottom and the sides? The sides is that the same pressure is experienced over here and over here, so it cancels out. That's the difference. Okay, now we are gonna. Now, as you know, you can understand from the figure that this pressure will always be more, right? This pressure will always be more than this pressure, because if we consider this height, let the height be h, let this height be h. And it comes to this pressure, it has more length or more height. It includes this d also. It includes d also, right? So since the equation for pressure is h rho g, as height increases, pressure increases normally. Okay, so we know that PB greater than PT, right? Okay. Now what is the area of this cube? We know that the side is d, so the area will be d square, right? D square. Okay, I'll put that over here. That will be d square. Okay, now what is the force? We said we have a pressure over here, we said we have a pressure over here. I need to know the force, the total force. So what happens with the force is that it will be the force over here, over this portion, total force I mean, minus the buoyant force. The buoyant force I told in Archimedes Principle, that is the net force. Okay, let the net force be Fn. Fn will be, since the equation for pressure is force by area, force will be pressure into area, right? So what is the first one? So the net force will be PB, sorry, the first PT, no, PB. Okay, PB into d squared. Now that is the area. Pressure into area is the force. PB d square minus PT d square. Now that's the net force, right? That is the net force. Okay, now I'm gonna make a change in the equation. So first of all, I'll bring out d square. D square into PB minus PT, right? Minus PT. Okay. Now, what is PB? What is PB in terms of the H rho G equation? PB is actually this H, this height, plus D, right? Plus D. I'll do it in another color. It's this height H plus D. That is what PB is. I mean, the height in the equation H rho G for PB is. So the other ones are same. Rho into H plus D, right? I mean do it in another color. Purple will be rho into H plus D into G, right? That is PB. Now what is PT? Rho into, as you know, PT is simply H. There is no H plus D. Rho into H into G, right? Now we expand this equation. D squared into rho HG plus rho DH minus rho HG, right? Now that's how we expand it. Okay, as you know, as you can see, this and this, they are equal, so we can cancel them, right? We cancel them off. Okay, so I need some more space. Move this off, or you know what, I'll just scroll down, it's better. Okay, now from this, oops, wrong tool. From this we get as Fn equal to rho Hg into d squared, right? Rho Hg, sorry, it's not rho Hg, it's d over here, so it's rho d, it's rho dg d square. Okay, it's rho d square, So when we multiply this, we get it as, oh shit, rho d cube g, right? We get it like this, rho d cube g, right? Now what is this rho d cube? D cube, you know, it's the volume, right? D cube is equal to volume. So rho is equal to density, and you have this equation, rho is equal to mass by volume. Ha! So you get m is equal to rho v, right? So this is d cube, that is v. So you get the final equation, mass into gravity. What is that? What is gravity? It's acceleration. You get it as mass into acceleration. Now that is the equation I wanted to derive from this. Okay, surprising, right? Now let me see if we have something else. Okay, okay, so I'll just once more tell you about Archimedes Principle. Simply write down it. It's quite important, that's why. Okay, I'm gonna delete this. Okay, so what Archimedes actually says is that the buoyant force, let me just underline, buoyant force is equal to the weight of water displaced. Now that's what Archimedes Principle says. Okay, I hope you have got everything you wanted, and in the next lecture we'll be doing a problem related to Archimedes Principle and the equations we have learned, and after that we'll be learning quite an important thing in fluid dynamics, the Bernoulli's equation. I hope you'll watch the next video. Thank you for watching this one. Thank you.